My name is Graphics. Today we want to solve another exercise on control system. We'll be looking at the control system with the unit feedback loop element, right? Now in this kind of control system, we call it a closed loop control system, right? And this system is whereby the control is achieved by automatically comparing the output with the input. So whatever is happening at the endpoint, there is a feedback mechanism that is telling the summer or the deductor that, oh, these are the adjustments you have to make, right? And the feedback helps to reduce the effect of what? Of disturbance. Is that taken? So when we compare the input and the output, if there is a resulting error, the error is used to regulate the plant, right? So we use the error to what? Regulate the plant by generating a command signal. So it is very important for a plant to have a feedback mechanism. So now let's see how we do this. In this case here, we have an input, right, coming into the summer. We also have a return output. That is, there's a feedback coming into the summer also. That means at this point here, we are having the output coming in here. And we also have what is called, this is the transfer function, and all these are the signal going in. So what you use most times in this kind of case, you can use a reduction of the system, call it probably a row reduction. So now what we'll do is, if I should redraw this again, right, I can have something like this. So we have this, right, reduction of the subsystem. Now what we do is, this is having a feedback, so that means CS is coming in, like I showed you earlier. So I place it there, CS is coming in, right? So what we'll just do is I'll put here to become my A. You don't put anything in between a control function and an output signal. You don't put anything there. So I have this way. So I'll start by doing it this way. So I'm going to say that let A be equals to, this is the error detector, right? Or we'll call it the summer, to be the RX. That means the input signal minus the output signal minus CS, right? I'll call it equation 1. Mind you, since there's nothing here, there is a silent what? There's a 1 here, a silent 1. So it means the CS times 1 give us our CX. That's why they call it a unit feedback. Unit feedback. Now, the next thing we do is CX now, which is the output. So we say the CS is equals to G1A. That is the transfer function 1 times the A. Now I'll call this to be the equation 2. Now we keep moving. At this point here, you say substitute A equals to this minus this, which is this, into equation 2. So we say that the output signal is equals to the transfer function G1, right, multiplied by A. And what is A? A is the input signal minus the output signal, right? So if I expand, you see the output signal is equals to G1, right? We have G1 times RS will give us G1 this, minus G1 times will give you G1 this, right? So if you look at it, you collect like terms. Because when I collect like terms, I have CS, I have CS here, and your output signal must always be at the left hand side, because the transfer function is the output over what? The input. So we say that collecting like terms, it will be CS plus G1 CX equals to G1 RX. So I've taken this to the other side, making the polarity to become a positive one, right? So we move forward. From here, what is common here? We'll factorize now. CS is here, CS is here. So if I bring CS out, I'm going to have the CX, open bracket. What is close to CS? The quotient of CS is 1, so left with 1, since I've brought this out, plus the quotient of CS is what? G1. So I write my what? My G1. And this will give us G1 RX. Now the first thing we'll do, the keyword is the output over the input. So we need to divide both sides by the input. So dividing both sides, divide both sides by what? By RS. That is the input, and that will going to give us CS, open bracket, 1 plus G1 equals to G1 RX. So this will be over RS, and this will be over RS, right? So RX will equate RX, and we will be left with CS into bracket 1 plus G1 all over what? RX equals to what? G1, right? Now the keyword is we want CS and RS to be alone, so we are going to divide both sides by what? 1 plus G1. So this will now give us, let's move forward. So this will now be CX into bracket 1 plus G1 all over RX into bracket 1 plus G1, because we're dividing both sides by 1 plus G1, equals to G1 all over 1 plus G1, right? So this we equate this, so we say that therefore C, the output over the input will give us G1 over 1 plus G1. So this is my answer. Now, if you found this video helpful, please don't forget to click on the subscribe button, and also don't forget to click on the like button. Watch out for the next video.